so today we're going to start up looking at just some basic algebraic expressions to get ourselves into the swing of things. Whenever we're looking at exponents, which at times can be a stickler, we'll talk about some of the reasons why that is here shortly, is just remembering what the parts are and what they represent. So if you see something like 2 to the 5th power, okay, 2 is called your base, 5 is called your exponent. This thing as a whole is called a power. So 2 to the 5th doesn't mean 2 times 5, which sometimes we confuse that for. It means I'm multiplying the base number 2 by itself this many times. So 2 to the 5th, 2 times 2 times 2 times 2 times 2 would be 32. Now can I punch that in my calculator and get it? Sure. Okay. But this just kind of lets you see where that comes from, because sometimes when we get into variables, there's not always going to be some place to do this with a calculator. So when we get into something where we start writing things as exponents, we take a peek and we go, okay, so I've got 3 x's here, but I'm not adding them together, so it's not 3x. I'm multiplying them, so it's x to the 3rd. I got a couple y's. Again, I'm not adding them, I'm multiplying them. And once I simplify those, I'm set and I'm done. So whenever we're talking about writing as exponents or simplifying, basically what we're doing is we're grouping off the parts that are alike. So all those 4 x's are the same. So I have 3 of those. I'd write that as an exponent. And then I've got 2 of these 3 y's. And I'd write them off as an exponent. Now, if it told me to simplify, I'd go ahead, distribute, and solve this. But here I'm just being asked to write as an exponent, so I can leave it that way and be content. So with any of these, you're like, okay, I got 4 of those. What about that minus 3 that's sitting here? Like, that doesn't go in here, does it? No. It's still on its own separate thing. Again, it's just getting the idea of what an exponent is and how we can condense it or how we could expand it a little bit. But here's the biggie. This, if I could, and I can, I'm going to double star this. This is the part when people are actually solving where I see the most errors start to take place. Because there's actually a difference between -3 in parentheses to the 4th power and -3 to the 4th power, no parentheses. And here's why. When I use the parentheses, we kind of look at it this way. I know a negative times a negative is a positive. So -3 times -3 is 9. Well, then I look at the next pair, and again, -3 times -3 is positive 9. And you multiply those together, you get a positive answer out. You're like, okay, I knew my rules before. I know that if that's even, it's going to come out positive. But if there's no parentheses, check out how that changes things. The negative isn't with each of the 3's anymore. It's just kind of out here by itself. So when I either go to the calculator or I pair them off like I did here, and I say, hey, 3 times 3 is 9. 3 times 3 is 9. And I get 81 again, but the negative's sitting outside the parentheses, so the negative doesn't go on until the end. It doesn't get multiplied out like it does with the parentheses. So I have to watch it. The calculator still can do this. You just have to know if you're using the parentheses or if you're not. Okay? Any issues so far? We haven't gotten into a lot of calculating yet. We'll get there. Just want to make sure that we're getting some of this before we do that. Nope, we're good. Okay. Order of operations. You've probably been seeing some of this since middle school. Now with these, I do want you to make sure that we're doing some of the steps and showing them so we don't do silly errors. Like here, okay, parentheses I always look for first. Do what's inside. It doesn't mean distribute the squared through. So just simplify what's in there. Then this is the other part that tends to stick people, because everybody wants to look at this and go, ooh, 2 times 3 is 6, 6 squared. No. Exponents come next. The exponent is just on what's in the parentheses. It's just on the 3. So I leave everything else alone and do 3 squared, which is 3 times 3. And now things kind of work out a little bit easier. But again, be careful. Multiplication comes before addition does. So I've got to do the 2 times 9 first. And then I can get my answer. Now, does it mean you have to show me like 3 and 4 steps in every problem? No. But the more steps you show me, if you have an issue, the easier it is for me to be able to find out what was going on and help you out a little bit. And that's going to be true through all of these. So I start to look, and I go, okay. Again, take care of that first. Now I start looking, and this is where I've got to be careful. Okay, I see the exponents working, but there's a difference. This one doesn't have the parentheses. So I do 5 squared, which is 25, but then I put the negative on at the end. Over here, the negative 4 is in parentheses because it was this quantity. Parentheses is going to come out positive because it's negative times negative. And then I can just do what I did before. So if you do it in your head or with a calculator, you're like, okay, 3 times 16 is 48. Good to go. And again, they won't always be long. Sometimes they may be short. Oh. On letter C, what should I do first? Multiply. Okay, it's in the middle, and we always think, I mean, especially if we're enjoy reading or things, we always think about everything as left to right. And that's good sometimes, but here I got to make sure that my multiplying gets done first. Now everything's adding and subtracting. I can just go left to right. 3 plus 20 is 23. Minus 4 is 19, and we're good. So again, order of operations, good old PEMDAS. Work our way through, get those situated. Well, what if we kind of blend the two things together? What if I give you variables, but I tell you what the number is as we're doing this? Here's one thing that's not written in here that I want to add, make sure that we get here. Whenever you're substituting, we always want to use parentheses. Because especially if you have a negative number, you're like, well, which situation is it from above? Is it at the parenthesis 1? Is it the not parenthesis 1? It's always the parenthesis 1. So when this says evaluate, that just means every time I see an x, I'm going to plug the value in that I've been given. And I'm going to use parentheses just so I don't get myself into trouble. Because then the order of operations take over from here. So I look and I go, okay, I got to do the exponent first. Ooh, it's parentheses, though. That's going to come out positive. Then it can get a little crazy here, though. I look at that and I go, okay. So I know multiply comes before subtract and add. So I'm going to do these two things where there's multiplying going on. Negative 3 times 4 is negative 12. Negative 5 times negative 2, be careful, negative times negative is positive. It's the only time in life where two negatives make a positive. And then I can just finish it off from there. Negative 12 plus 10 is negative 2 plus 7 is 5. Kind of closing in here on some things. I'm not going to go crazy on the bottom and do all of these. I want to give you some time to be able to get stuff done. But again, when we're doing this, combining like terms, again, 2x and 4 are the terms. Wherever you see a plus and minus, that's when terms separate. Okay. 2 is a coefficient. It's in front of a variable. 4 is a constant. It's just a number. There's no variable hooked up with it. And again, like terms, the ones with the variables are like. The constants with no variables are like. And then we just put them together. So like here, they're the same, okay? I can put them together. It's not x squared. I'm not multiplying them. I'm just putting together the things that are alike. The other stickler that tends to get people is when there's no coefficient. Remember, when there's no coefficient, there's still a 1 there. So this is 3 minus 1. 2n squared plus n. They both have n's, but this has an exponent, so they're not like terms. I can't put them together any further. Okay. Distributing, we've done some of that in here before. I'm going to go over these two because we're going to see it again in number 5. Just like we said yesterday with the worksheet, when you see parentheses, we deal with those first. We distribute. 4 times 5 is 20. Now I do have to watch it. This isn't x plus x, x times x. X times x is x squared. 4 times 4 is 16, and I just have the x. There's no other x to multiply by. And the negative 18x isn't even in the parentheses, so it doesn't get any of the distributing. Once I have that set, once I have that distributing done, I just go back and I look for the parts that are alike. No other x squared, so that gets left alone. And again, think about money. If I got $16, ooh, I just spent 18. I spent more than I have, so now I'm $2 in the hole. And I go through and work that. Got the ones on the edges here on the bottom I'm going to do too, and then I think we're going to keep rolling along here. So for number 6, lots of distributing. And again, it's one of those things that if you can do it in your head without arrows and things like that, there's nothing wrong with that. Make sure when you're distributing on the second one, though, that negative 3 is going with. That's what we're treating it like. So like here, negative times negative is positive. It's one of those little details that if you go too quick, you can miss that pretty easily. And then just go back and look for the like terms. But again, now we're adding and subtracting. So we don't mess with the exponents like we did back here when we were distributing and doing x times x. And then 2 plus 12 is 14. Keep life simple. And again, speaking of the simplicity, don't let something like a decimal freak you out and think you immediately need to go to a calculator on it. Because if we think about it for a second, what's like the fractional value of 0.5? Yeah, 0.5 is a half. So basically I'm just saying, okay, half of 8 is 4. Half of 6 is 3. So that wasn't too bad. And then I just multiply, I distribute my negative 3 to my last two terms. And that's one of the reasons I like doing the arrows, just so I don't forget. And then just put together the things that are like watching the signs in front. Got $4. Oops, I spent 6. I'm in the hole. I had $3. Dang, I spent 12. I got to get this spending under control. I'm 9 in the hole. And those are the type things that we're looking for. Okay? Anything question-wise before we head to the back? Just going to kind of finish this off back here. Again, a little bit, big part of what we're going to be doing here is going to be problem solving. So like here we got $50. We're going to buy some movies on video cassette. Holy cow, some of you have probably never even seen one. They cost $15 each. Write an expression that shows how much money you have left after buying n movies. Evaluate the expression when n equals 2 and n equals 3. Okay, so our verbal model here is we take our original amount. Well, in this case, that's $50. And then we're going to subtract some kind of an amount. Well, to figure that out, I need to know the cost of each cassette, and I need to know the number of cassettes that I'm purchasing. And I multiply those two things together to see what the cost of that is going to be. So in this case, I know how much the cassettes cost. They cost $15 each. Do I know before I get to this part how many I actually purchased? I don't. So in math, this is where the ever-loving x comes in, a variable that stands for a number. So my equation would be, and they want me to use n. I'm going to use x, I don't care. So this would be my expression or my model. And then to figure out what I'm being asked, if you used n, good job, you were reading better than I was. And it just becomes substitution. I take my x or my n and I plug the number in. And then again, being careful to follow order of operations, I multiply. 15 times 2 is 30. And 50 minus 30 means I'd have 20 bucks left. If I buy 3 instead, 15 times 3 is 45. 50 minus 45 is 5 bucks. And like it says here, multiplying the price by the number is what gets us the cost that's being worked in here. So one more of those. Okay, you want to buy a CD or a DVD as a gift for 10 people. CDs cost 13, DVDs cost 19. Write an expression for the total amount you must spend. Then evaluate the expression when 4 people get CDs. Okay, sometimes we throw in there what's called a distractor. You want to put all the numbers in the equation. You want to put in the 10, you want to put in the 13, you want to put in the 19. But the only parts that have costs with them are the CDs and the DVDs. So those are the only ones we're going to put in. So I look and I'm going to say, okay, I'm going to have a CD be C, and I'm going to use D for my DVDs, just so I know whoever's looking at this knows which thing is which. So I look at the first part and I go, okay, CDs cost $13 each. So price times quantity, $13 times the number of CDs that I'm purchasing, plus the cost of a DVD times the number of DVDs I have. I don't know quite yet. And that's going to be my total cost. You're like, so I don't use the 10 anywhere? Not in that problem, but we're going to get to use it here in just a second. Evaluate, solve, when 4 people get CDs. Okay. 4 people get CDs. How many people are going to get DVDs then? 6. If 4 out of the 10 here, I've got 6 left. And now I can go ahead and get my cost by multiplying this out and adding them together. So sometimes it is, we've got to build the problem, we got to plug in the numbers, and we got to find them. But don't skip these, because these show up a lot in places. We just got to learn to work through them like anything else. More practice, we'll get better at it. And again, I'm just going to do a couple of the ones in evaluating with some more here, especially when we start getting into some of the fractional values and the negatives and all that other fun stuff. So let's do some craziness here. I'm going to do, let's do B. D looks awful, so let's do that. And let's do F, just to get a little bit of a flow going here. So again, when I'm doing these, like, okay, 3 times x. So 3 times 3 squared minus 7 times 3. So let's see here. parentheses first, so 3 times 3 would be 9, so 9 squared minus 7 times 3. I'm going to do 2 steps together on this last one. Exponent, remember, 9 squared is 9 times 9, so 81. 7 times 3 is 21. And I can get to my answer that way. You're like, that's not very nice. They give you 2 x's. I didn't put a y in there. Well, sometimes it just works out that way. Yeah. What? And I'm caught on video in the world forever. What am I ever going to do with myself? Okay. Oh, we got fixing to do. All right. Another reason out there, even the math teacher should not be using pen doing this stuff. Oh. All right, let's get that fixed. 3 squared is 9, times 7 is 63. Thank you. Let's try that again. All right, so 18, much better. Yeah, I got to pay attention to detail. I bark that at everybody all the time, then I don't do it. All right, let's see if I can do a little better here on this next one. Okay, on letter D. Ooh. 5 times x is 6. Uh-oh. The infamous fraction. One of our Algebra 2 F words, along with factoring when we get there. Ooh. Minus 6. Now I got to make sure I did this all right. Okay. So here's where our options come into play with fractions. Could I do this on a calculator? Yes. Are there some things that could go wrong on the calculator? Yeah, there are. But let me show you some options here. Also give you an advanced look here at one of our tools that we can use. I've got this on the front of my website for you to be able to download if you've got a computer at home that you want to be able to play this on and be able to have the same calculators that we have here in class, just play with it on the computer. So how would I deal with this? Well, one way I can do it is I can do 6 divided by, but if I do it, anytime there's a fraction, I've got to make sure the fraction is in parentheses. Because otherwise, it would just go from piece to piece to piece. That's not going to do me any good. And this one actually came out nice, which is terrific. So here, once I've got this craziness dealt with, so it's basically 5 times 9 minus 6. And we'll get into talking as the semester goes along, some other ways we can deal with that fraction, maybe even a little bit easier of a way. 5 times 9 is 45 minus 6 is 39. Good to go. Okay. Now those have come out nice. Are they always going to come out nice? Yeah, probably not. So on this last one that we're doing here, let me scooch over a little, with f, so x squared again, especially with negatives, make sure we're putting the parentheses in there. And then 2 times y plus 1. I go, okay, with the parentheses, again, I can put it in the calculator, but I think I got this one. Negative 3 times negative 3 is 9. 2 times 2 is 4, because multiplication comes before add, plus 1 is 5. Now, if you went to type all of this in the calculator, you're going to get like 1.8 out. So like if I'd have said, well, I'm not feeling comfortable with this whole fraction thing, so let me go to the calculator. Now here's some of the cautions that you're going to have to take. I would do it piece by piece if I was going to do that. Because here's what I think would happen to quite a few of you if you tried to do it this way. You'd be like, all right, I got this. So I'm going to do negative 3 squared. I'm just going to type in everything like I see it, on my paper. So then I hit the divide, and I do 2 times 2. All right, plus 1. I'm going to get the right answer. Here we go. 10. Harty screwed this up again. Not this time. But here's what happened. The calculator does order of operations. It did this, but then it did divided by 2. And then it times by 2 and a plus 1. You're like, that's not what I want to do. So if you're going to do it all in the calculator, like I said, I would do it in pieces, because then this won't happen. You'll get your 9 and you'll get your 5. But again, 9 divided by 5, yeah, I don't want 1.8, okay? Just leave them. If you get to a decimal sometime, you just hit math, and then you just hit enter twice, and it'll put it back into the fraction for you. It'll make it a little bit easier as you're doing those. But again, just do fractions, do all the top, do all the numerator, done. Do all the denominator, done, and then put them together at the end. It'll solve you a lot of problems. All right, last part, it's the geometry review, people. It's early in the year. Geometry should be fresh in your brain still from last year. Okay, write an expression for the area, then evaluate it. Oh, wait a minute, the area. Area of a triangle, how do I find that? Okay, half a base times height, or I can just write it base times height divided by 2, or you can write the 1/2 in front. So I look at this and I say, okay, well if n is 40, it means my height is 40, 40 plus 10 is 50. So basically what I'm going to do is I'm going to do 40 times 50 divided by 2. So let's see here. If I punch that in, it'd be 2,000 divided by 2. And I'd keep suggesting some of y'all keep an eye on me, because this could be one of those days. But I believe I'm going to get 1,000 here. But again, if you're going to the calculator, numerator, then denominator, put them together at the end. What about for a rectangle? A little simpler of a formula. Yeah, just base times height, or length times width, however you want to look at it. So again, plug in your numbers. 8 plus 3 is 11. Oh, so I just multiply them together. 8 times 11. And I'm set. Now, a square, since they're all the same side, there's a couple of ways I could do this. The actual formula for the area of a square is taking a side and squaring it. Could you do base times height again? Sure. Since all of them are the same size, 12 plus 5 means one side's going to be 17. So I would just do 17 squared, which is 289. So, again, here's your job in all of this. Back on the front, up at the top, is the actual book assignment for this. And again, I'm not trying to hammer you on this by any means. 2, 4, 6, 8, 10, 12. Okay, whoa, not even on the screen. 13 problems. Okay, doing a little bit of everything here. Again, if you haven't already, I date this just so I remember, when we did some of this. So if you want to get a head start, the books are up there in the stacks. Go ahead, get those situated. Get a little bit of a start on this. And then